Runout is caused by a bent shaft or by eccentricity of the coupling. Eccentricity literally means being off-center. It can occur if the coupling is not bored in its physical center, or if the bore is bigger than the shaft and the set screws pull the coupling out of center. When measuring runout, the dial indicator is mounted to a fixed point in space. If the coupling is disconnected, attach the dial to the shaft opposite the one you want to check. Or if the coupling is connected, you can use the mag bracket to mount the dial indicator to the base of the machines or any other fixed point in space. We recommend that you first check for runout at the hub or rim of the coupling, because there you will pick up both eccentricity and bent shaft. Some people will also measure runout in the axial direction, which, in addition, would tell you if the coupling bore is skewed. Before taking the readings, make sure the dial is mounted perpendicular to the shaft. Set the plunger to half its travel range to assure both negative and positive capacity. Once the dial is affixed, rotate the shafts. Make sure you rotate in only one direction. Find the greatest distance from zero in either positive or negative direction. Stop rotating the shafts and reset the dial to 0. Now, continue rotating the shafts and watch the dial for the maximum amount of change, which equals the total amount of runout. If the runout is within acceptable limits at the hub, 2 thou or less, then the coupling must be bored properly enough and the shaft is reasonably straight and within acceptable limits. In this case, the dial is indicating excessive runout of 22 thou. When excessive runout is observed, we next need to determine if it is being caused by a bent shaft or by an eccentric coupling or both. We achieve this by repeating the same measurement process at the shaft. You'll want to take the measurement as close to the coupling as possible. In this case, there is 21 thou of runout at the shaft, accounting for most of the 22 thou of runout we observed at the coupling. Therefore, the bent shaft is the problem. If our measurement at the shaft had been close to 0, the problem would have been eccentricity of the coupling. Of course, we could observe a situation where both conditions occur, a bent shaft and an eccentric coupling. If excessive runout is present, it should be corrected before attempting precision shaft alignment.